So in 6.1, we're converting between fractions, decimals, and percents. Fractions, decimals, and percents. Do you have it labeled up? Okay. So you need to know how to convert between them. Between a fraction, a decimal, and a percent. They're all interchangeable. They all represent the same value. 50%, 0.5, and 1/2. Does everybody agree? Those are all the same value. Yes. Everybody agree? All right, so now I want you to fill in for 25%. Go ahead and fill in your decimal and fraction values for 25%. So what's the decimal version for 0.25? 0.25. I'm sorry, I said it. For 25% is 0.25, yes. And what's the fraction? 1/4. Okay, very good. All right, so there we go. So slide 2 kind of shows us, really in a nutshell, you say, this is the most questions you've ever put on a slide. I would probably agree with that. But they're all so closely connected. Look at the title of each section. Percent as a decimal, and then decimal as a percent. I'm just going back and forth. Okay, so one thing we need to understand, all right, that's happening here. If I take a percentage, if I say there's an 80% chance of rain today, 80% out of what? 100. Out of 100. So although it doesn't say to write it as a fraction, would you agree that 46 over 100 represents the same value? Because it's 46% out of 100% chance. So if I want to write this as a decimal, my denominator tells me the place value that the last number should be in, okay? The hundredths place. This is 46 hundredths, all right? Do you see that? So 46%, any percentage is out of 100. So if it's out of 100, then that value needs to be written so that the last digit is in the hundredths place. All right? It's 100, 46 hundredths. That's how I write it as a decimal. Another way to look at it is in order to change a percent to a decimal, essentially I'm dividing by 100, so I'm moving my decimal to the left 2 places. Do you guys remember learning that? All right? That's okay. Guys, I'm perfectly fine with you doing it that way, but you have to understand why it's moving left. It's moving left because I'm dividing, all right? And I move my decimal left. All right, so based on that, now this whole fraction here, you don't have to write that in your notes, okay? I want you to change 245% to a decimal now. All right, anybody want to give me that answer? Caden, what is it? What'd you write as a decimal for the second one? 245. What is it? 0.245. You're close. You moved it too many. You moved it 3. You should just move it 2, Xavier. 2.45. Very good. 2.45. And doesn't that make sense, too, that a percentage that's more than 100 is going to be more than 1? Okay, 2.45. Number 3 is a repeating decimal, but does that change how many decimal places I'm moving? No. No, but what needs to be in my decimal value? The repeating bar. Okay, so it should be 0.126 repeating. Moving my decimal left 2 places. All right, any questions about percent to a decimal? Left 2 places. So guess what we're going to do for a decimal to percent? Guess which way we're going to move? Right 2 places. All right, go ahead and try to write your percentages for 4, 5, and 6 now. All right, so remember what we said about out of 100. Do you agree that you would read this decimal 5 hundredths? Does everybody agree that 5 is in the hundredths place? Do you see that? So essentially what I'm saying is 5 100ths, right? Again, you don't have to write it as a fraction, but I want you to see what we're doing here. Anytime it's over 100, your numerator represents the percentage, right? 5% out of 100%. So when I say that it's 5%, all right, what I've essentially done is I've put this into a fraction, and I'm reading the fraction, 5%. Or you could view it that I'm moving my decimal 2 places to the right now versus 2 places to the left in the last section. All right, so next one. Avery, what did you write for your percentage for number 5? Very good. Do you agree with her? 125%, 2 decimal places to the right. What about your last one?
0.42%.
Yeah, so there's 4 decimal places in your number. Did I say move all the decimals out of the number? Is that what we do to convert it?
No.
We only move it 2 decimal places. So it's still going to be 0.42%. The decimal is still in the percentage. Don't let that throw you off and think, oh, I'm not supposed to have a no, sometimes you do. Sometimes they give us really, really small numbers to test whether or not we actually know our rules, okay? So that's correct. So now let's look over here in the second column. Well, in the second column, I need to write the fraction as a decimal and as a percent, and we are not using our calculators, okay? So if you're using our calculator, that makes it really easy. So what we're going to do here is we're going to focus on our denominators. If our denominator represents a place value, it's easy. 10, tenths. Think about tenths. Is there a decimal place that represents the tenths place? 0.7. So we're going to put that number in that place value. Do you agree that 7 is in the tenths place? All right. So if the denominator is one of my place values, I put the numerator straight into that place value. Okay. And now can I change the decimal to a percentage? What is it going to be? 70%. And I'm done. Okay. Now, my second one is more challenging. Why? Because is there such thing as a ninths place? No. So I must do long division to get my decimal value, and I must go out 3 decimal places. Okay? So go ahead and do long division, 5 divided by 9, to come up with your decimal value. Remember, the top number is always on the inside, 5 divided by 9. Okay? 5 divided by 9. Go ahead and do long division, and we have to go out 3 decimal places. Does 9 go into 5? No. So what do you do? Guys, quiet. What do you do? Add that decimal and that 0. Does 9 go into 50?
No.
Yes, it does.
Oh, yeah.
5 times 45. 5 left over. Now what do? I got to keep going.
Add a
0. 9 goes into 50. 5 times 45. Oh, man. What do you notice, guys? Yes, it's a repeating. That is true. That is true. But you need to know what the value is going to be. All right, so 0.555 repeating is your decimal. Okay, the 5's repeating. All right, now how are you going to write that as a percentage?
55.5%.
And a half. Now, don't forget your repeating. Percent. Okay, so there's my decimal and there's my percent. All right, so if your fraction, if the denominator does not represent one of your place values, you're going to have to do long division. And it more than likely will be a repeating decimal. All right, so now I want you to try number 9. I'm going to have to switch screens so we have room. I want you to do number 9 now. 3 over 1,000. Okay, so this one's a little easier because is there such thing as a 1,000ths place? Yes. Okay, so put the 3 there for your decimal. All right, Noah, what did you write for your decimal? Good job. Wait a second. Why did he go out so many? Because 3's in the thousands place there, right? If I had put it in the second one, that's 100th. All right, and so how do I write that as a percentage? 0.3%. All right, who got that right? 0.3%. Raise your hand if you got it right. Okay, good. Oh, man, 17 over 15. Is that one going to be even? No, so do your long division one more time. All right, you're going to have one of these on here. And guess what, guys? On your homework, if you don't have the long division shown, you're going to lose points, like all the points for that question, because you're supposed to be doing these by hand. So even though you have your calculator's not going to show the work. All right? So 17 divided by 15. All right, long division. Go ahead and work it out. Get your decimal and your percentage. Okay, can 15 go into 17?
No. Oh, yes.
Yeah, one time. So then 15, and I bring down my 20. Does 15 go into 20?
One time.
One time. And then that's 15. And then I have 5 left over. Bring down my 0. 15 go into 50?
3 times. 45.
45. Oh, man. I see my repeating again. Then I have 50. So I go 3 again. And the 3, guys, only the 3 is repeating. The 1 does not repeat. 1.13 repeating. And then as a percentage, what is it going to be, Zach? What's it going to be as a percent? Yes, 0.3 repeating. Don't forget the repeating and percent. All right. Now number 11. Number 11. Okay, is there such thing as a fourths place?
No.
No, there isn't. So I could do long division. However, if you're like me and you kind of want to avoid long division at all costs, there's another way you can solve this. If your denominator, if you can multiply it by some number to make it equal to one of your place values. So 4 times some number, which I don't know. Okay? So we'll start with a tens place. Can I multiply 4 times something to get to 10?
No.
You could. It's not a whole number, though.
Yes.
What about 100?
Yes.
Yes. So I can multiply it by 25. You see what I'm doing here? I'm making it so that my denominator is one of the place values, 100. Okay? Now, I couldn't do that here because 15 times nothing equals 100, okay? Not nothing, but not a whole number for sure. Same with 9. But if the denominator can be made into 100, I can avoid the long division. What's 22 times 25? 550. Okay? All right. But it doesn't say to write the fraction as a bigger fraction. It says to write the fraction as a decimal, which means that I'm moving now my decimal left 2 places to divide by 100, 5.5. When I divide by 100, Miles, I'm moving my decimal. That's 5.5, guys. Okay, and what is it as a percentage? 550%. Okay. All right. Y'all did well on that. Now, on the same notes, I want you to title up the percent proportion. So that was a review because I know how much repetition you get on that concept in the 6th grade. We don't need to spend a whole day on that. Okay? Now that springboards us into the percent proportion, which is a concept that if you learned it last year, you didn't spend as much time on it as, we'll spend this year, okay? So we're going to kind of slow down now for the rest of today's lesson and go through solving percent problems. All right, the first thing you need to know is your formula, okay? Now, you have 2 formulas, and I'll explain why in a minute. They're the exact same thing. A over W equals P over 100, and is over of equals P over 100. All right, I'll explain in a minute why you have an option between both, but for now, just go ahead and write down both of them. Okay, so A over W equals P over 100, all right? We need to understand what each variable in the proportion means. A stands for the part, so I want you to write that in your notes. A is the part of the whole, okay? It's the part. And the key word here is, which is why you see is in the same location on the other formula. It's basically saying this is my key word, all right? Is. W stands for the whole, and my key word for W is of. All right, now those key words are important because when I'm reading these statements, I need to understand which value belongs with which variable. My keywords tell it to me. All right, so if I see of some number, I know that's my whole. That's my W. If I see is and then some number, I know that that's my A or my is value. All right, so let's read the first statement. What percent of 15 is 12? So I'm going to use my formula. Now your formula is your original problem. On your homework, you do not have to write the statement. You must write the formula. So we're going to keep practicing. All right. And again, it doesn't matter which one. I like to choose is over of. Is over of equals P over 100. Okay. So which number, based on the statement, is your is value? 12. Guys, right here. Right here. 12 is, and 15 is of, and I don't know P. It says what percent. I don't know the percent. So now, once I set up my proportion, I'm going to use cross products to solve. 15 times P and 12 times 100 to get 15P equals 1200. So if you were shaky on solving proportions on your test, you're about to get a ton of practice on solving proportions. But now we have to use percent equation to set them up. Both sides by 15, calculators allowed. And P equals what?
80.
And don't forget to write your percentage. Okay? So now I want you to try to set up the second one and work with your buddies, work with your group mates, all right, to try to set up your proportion and solve it using cross products. All right, so I have 24 over 20 equals P over 100. All right, but something's different here. 24 is supposed to be the part, but it's actually bigger than the whole. So what does that immediately tell you about what your percentage is probably going to be? It's going to be bigger than 100. 20 is 20% of 100, so 24 is going to be more than 100%. Okay, so you get 20P equals 2400. Okay, divide by 20, both sides. And the percentage is 120%. 120%. All right, did anybody get that right before I put it up there? Good. Okay, example 2. Man, example 2 looks a whole lot like example 1. Okay, don't these statements look pretty similar? Except now, let's read them. It says, what number is 80% of 60? So now I'm solving for a different part of the same proportion. Now I know my percentage, and I'm solving for is. It says what number is. I don't know it. All right, so let's use the same formula. All right, now here's where the first formula goes into play. If I'm solving for is, I need to use the variable A. If I'm solving for of, I need to use the variable W. Okay, that's pretty much the only reason I use that formula. Okay, so we start with is over of equals P over 100, our template. And then is what I don't know, so that's why I use the variable A. If I'm solving for is, I use the variable A. Over, what's my of? 60 equals 80 over 100. Now, usually if I'm plugging in a percentage into an equation, I need to convert it to a decimal. But the reason I can leave it 80 is because what is it automatically over in the formula? It's over 100, so essentially the formula is converting it for me. That's why I can just plug in 80 straight into my formula. Cross products and solve. 100A equals 4,800. Divide both sides by 100. And A equals 48.
Bam.
Now, do I need a percent sign?
No, because it doesn't ask you what.
No, because
number,
A is, yeah, very good. A is not a percentage. All right, now solve the second one. You solve the second one now. All right, okay, so I have A over 40.5 because that's my of. My is what I don't know, so I use the A for the variable, equals 10 over 100. That's my percent. So I get 405 equals 100A. Divide both sides by 100. And A equals 4.05. All right. I think Kennedy got it. Anybody else?
Yes.
Anybody else get it? Sarah, did you get it? Avery, did you guys get it? Okay, 4.05. All right. So we've solved for A. We've solved for P. Guess what we're going to solve for now? W. W. So here's what it looks like in a statement. Guys, on your homework, it doesn't say which one you're solving for. You have to be able to read the statement. You're not listening. Okay? Please stop talking. You have to be able to read the statement and figure out what you're solving for. So here's the key. It says of what number? You don't know the of. But you can't write of in the denominator. You can't write OF and solve for of. So what's the variable that stands for of? W. Okay? 9 over W equals 25 over 100. 9 was my is. 25 was my P. I plug them in and I solve for W. Go ahead and do your cross products to solve. All right, 25W equals 900. Divide by 25. W equals 36. Who got it? Who got it? Good. Now, I want you to set up the last one completely on your own. Use your cross products to solve. Raise your hand when you get the answer. I'm going to come check. All right, so 30 is my is. I don't know my of. W is my variable for of. That's what it says up here in this formula. W is my variable. Okay, equals 150 over 100. I do my cross products, and I get 150W equals 3,000. Divide by 150. And now you can talk. W equals 20.
Yes.
20. All right. So, and does that make sense? Because it should be more, the part should be more because it's 150% and the part was 30. All right, so it's rational too. All right, so let's read our example. An Arctic woolly bear caterpillar lives for 7 years and spends 90% of its life frozen. Oh, hold on, I have a misspell. Days. I meant to correct that. Oh goodness. That's where my Y went. How many days of its life, hold on, is it frozen? Okay, so I need to figure out what's my A, what's my W, what's my percent. I got to plug them in. Well, what's the easy one? 90%, okay? So let's go ahead and fill in that side. I know this side is 90 over 100, okay? Now I need to figure out what does this 7 years stand for? Is that my total, like overall, or is it only a part of the total lifespan?
That's the total. Total life.
Yeah, so it says how many days of its life. Now don't be, guys, here's the number one mistake I see. I see, oh, well, it said my keyword of. How many days of its life? So because it said the keyword of, that means I'm solving for, or that means that's my W. That's not true. That's not what you're doing here. It's saying just how many days of its life. So if you're only counting certain number of days of its total life, you're actually solving for the part. All right? Is. 7 years, though. 7 years, and it's asking for days. 365 times 7. In order to figure out how many days, I have to write years in days.
Okay, so it's 2,555.
I thought it was 22,000, no?
It's
2,555, that's correct. Okay? And I don't know how many days of the 2,555 it spends frozen. I know that it's 90% though. So now that I have my proportion, I can use my cross products to solve. Go ahead and do that. What's 90 times 2,555?
299,950.
229.
Yes, 2,000.
What?
Hold on.
Oh, here's the answer.
Hold on. It's 229,900. What is it?
229,000.
Yes, that's correct. Okay, equals 100A. Divide both sides by 100. And
2,299.5.
yes.
That's a lot.
Okay, so you could say it's pretty close to 2,300. Now, is there such thing as half of a day?
No.
Yeah, 12 hours. Now, if I had said, if that was caterpillars, is there such thing as half of a caterpillar? Okay, so it depends on, guys, we're almost done. It depends on what you're measuring. There is such a thing as half of a day, so that's okay. Now, if it's a person or whatnot, there's no such thing as half, so you would have to round up, okay? And that's everything you need to know for section 6.1 and 2.